So in this video, we are going to look at how to begin factoring polynomials of higher order than quadratic functions. We know how to factor quadratic functions. It's fairly straightforward. So now we're going to bump it up. So there are some functions. Many of these will be cubic in the examples we do, but they certainly could be other degrees of polynomials that can be factored by grouping. So we have two examples here, and we're going to do both of them. The first example is 2x cubed plus 5x squared plus 6x plus 15. So like the name inspires, we want to group these. Notice that the powers are in descending order. This is what we would call standard or general form of a polynomial. So I'm going to make two groups. I'm going to put the first two terms in one group, and then I'm going to put the second two terms in the other group, and I'm going to add both of these factors. What we're trying to ultimately do is distribute backwards. And I challenge you at the end of this video to pause it, look back step by step from the end to the beginning, and show how distributing really works. And you're going to look for the GCF of both terms and then factor them out. So in this case, the highest thing that they have in common is x squared. So I'm going to factor out x squared. So I have 2x plus 5. And then I'm going to factor out the GCF of the second pair. The GCF between 6x and 15 is 3. So I factor out 3, and then let's keep going. I have 2x plus 5. Now notice something incredible has happened. These two factors in each term are the same, 2x plus 5. So if we think of this as our first term and this as our second term, they now have a GCF, a greatest common factor. And that factor is 2x plus 5. So we can factor out the GCF again. So we have 2x plus 5, that's factoring out the GCF. Left over from the first term is x squared. Left over from the second term is plus 3. Now pause the video and ask yourself, is this expression completely factored, or can we factor it further? Now you might have gotten held up that this is x squared plus 3, and 3 is like not a square number. But as it turns out, we can use our fundamental theorem of algebra to factor it further. So it's helpful to think of solving the equation x squared plus 3 is equal to 0. So we subtract 3 from both sides. We take the square root of both sides. And then we simplify. So x equals plus or minus the square root of 3 times I. And notice that that I is not inside the square root sign, but outside of it. So we can write our fully factored expression, 2x plus 5 times x plus the square root of 3 times I times x minus the square root of 3 times I. And notice that these are conjugates, so it satisfies our conjugate pair theorem. And this has been how we can show this example, factoring by grouping all the way to the end. Now this was a fairly straightforward example. So I do want to do a second example of factoring by grouping that we already have written out. So this might also be a good time to pause the video and see if you can at least set up the first few lines of factoring by grouping. If you can't, then just hit play and keep watching. But if you can, you're checking your understanding and reinforcing what you're learning. So example 2 says factor by grouping 18x cubed minus 45x squared minus 8x plus 20. Last chance to pause the video before we begin solving it together. I really encourage you to attempt it on your own to see if you can. So I'm going to first set up my groups. So I have 18x cubed minus 45x squared. And then I'm going to have plus negative 8x plus 20. Now, one place that I see students get confused often is they want to divide that 8x plus 20 into its own group without having the negative sign. We always have to group initially with a plus sign in the middle. Now, pause the video again, see if you can identify and factor out the GCF from both terms. Presumably, you've done this already, and you found that 9x squared is the GCF of our first term, leaving 2x minus 5, and then negative 4 is the GCF of the next set. That's negative 4 times 2x minus 5. Now, if you hadn't factored out the negative sign, you would not have these two factors match. So that's a good cue to go back and factor them. It would only be off by a negative sign, so at that point it should be pretty straightforward to see. So now we can separate these into two different factors, 9x squared minus 4 and 2x minus 5. So we're now finished with the factoring by grouping part. Pause the video again and see if you can further factor this expression to a product of linear factors. Hopefully you've recalled the difference of squares formula, which says 9x squared minus 4 can be factored as 3x minus 2 times 3x plus 2, and then we carry down the remaining factor of 2x minus 5, and this is now the complete linear factorization of 18x cubed minus 45x squared minus 8x plus 20. So oftentimes when we're working with larger polynomials, we'll want to keep an eye out for anything we can use. For example, quadratic factoring or factoring by grouping. Again, the big thing to remember is factoring by grouping only works when we get the same expression inside parentheses. If the expression doesn't match, then factoring by grouping doesn't work, and we need to try a different approach.